So good evening, students. Good evening to all. So am I visible and audible to you? And just let me know in the chat box if I am visible and audible and my screen is visible to all of you. So good evening, students. Good evening to students. Am I audible? If I am audible and visible, just let me know in the chat box. Students who are watching from YouTube and from Zoom, just let me know. Yes. Thank you so much. Thank you so much. So moving on to today's class. So today we are going to discuss some questions related to aldehydes, ketones, and carboxylic acids. So myself, Anandi, and I'm going to deal with the thing today. And last week, we have discussed few questions related to aldehydes and ketones, right? So in the preparation of aldehydes and some of the chemical properties of aldehydes and ketones and physical properties of aldehydes and ketones and preparations of aldehydes and ketones. Those topics we have covered in the last week. Okay. Now in today's class and tomorrow's class, we are going to discuss the remaining chemical properties of aldehydes and ketones. That is aldol condensation reactions, Cannizzaro and electrophilic substitution reactions of aldehydes and ketones. And next, the carboxylic acid part fully. Okay, that is a whole preparation, physical properties and chemical properties of the whole carboxylic acids. Okay, so I'll go for the first question for today. So let's start with the previous year's questions. So all the questions what we are going to discuss, they are previously asked questions only for the JEE and NEET. Okay, so here is your first question on your screen. Just see to the question. A compound is given to you and the compound is treated with diol H and H2O. So consider the above reaction and predict the major product. Consider the above reaction and predict the major product. So I'll give you just 30 to 45 seconds. I'll give you. Just try to find out the product and let me know in the chat box the correct option. So I'm waiting for your response. Just to find out the answer quickly. If you have got the answer, just type it in the chat box so that we can discuss. Which is very easy. Just the complex looks a little bit bigger. Okay. Just try to find out the answer. Okay, we'll discuss the compound now. So here you can see diol H is present. So what is diol H? It is diisobutyl aluminium hydride. This diol H will convert both the ester group as well as the nitrile group to the corresponding aldehyde group. Okay. So diol H will convert ester and nitrile to aldehyde. So in the given compound, you can find out that here we are having an ester group. This is R. This is COR, COOR, RCOOR. This is the ester part. And here we are having the cyanide part, that is the nitrile part here. And both the compounds will get converted to CHO, that is the aldehyde. So which is the correct option? Which is the major product for this reaction? It is option number 1. Only in this option, both the compounds are getting converted to CH. Okay. Ester group, that is COOR, as well as the cyanide group, they are getting converted to aldehyde. Got it? Shall we move on to the next question? Okay, I'll go for the next question. So option 1 is the correct answer. So coming to question number 2, CH3, CH2, CN on reaction with methyl magnesium bromide in presence of ether gives A, and A on hydrolysis gives B, then B with zinc amalgam, that is zinc mercury, and HCl forms C. So what is the correct structure of C? Again, for this reaction, you can take 15 to 20 seconds or 30 seconds. Let me know the answer in the chat box, then we will discuss. So students, can you try for the answer? Just try for it and let me know in the chat box which option is correct. 1, 2, 3 or 4. Okay. So we are taking CH3, CH2 and CN, right? So this is the given compound, and this compound is treated with CH3 MgBr. Okay. So what happens here? CH3 is the partially negative part and MgBr is the partially positive part. So break this bond, add the negative part to the carbon and positive part to the nitrogen. So what you will get? You will get CH3, CH2, C, CH3, double bond, nitrogen and MgBr. MgBr. So this is compound A. And compound A on acid hydrolysis, that is on reaction with H3O plus, what happens? The component which is present or attached to the C double bond, those whole component will be converted to oxygen, right? So we will get CH3, CH2, C double bond O and CH3. So this is compound B. We are getting a ketone which is called as butanol. And this compound B on treatment with zinc amalgam in presence of HCl. So what is the name of this reagent, zinc amalgam and HCl? It is Clemmensen reagent, right? So this is the Clemmensen reduction. So in Clemmensen reduction, what happens? The C double bond O group will be converted to CH2. So at last we get CH3, CH2, CH2 and CH. So this is compound C. CO will be converted to CH2. So what we are getting? We are getting option 1 as the correct structure of C. Okay. So option 1 is the correct answer for this question. So do you have any doubt here in this question? If you're having any doubt, just let me know in the chat box, or else we can move on to the next question. No doubt? Okay, I'll move on to question number 3. So among the following acids, which has the lowest pKa value? So 4 different acids, carboxylic acids are given to you, and you are asked to find out the carboxylic acid which has lowest pKa value. So how to find out, and if you have found out the answer, just put it in the, type it in the chat box. Put it in the chat box. Type it in the chat. Students, those who are watching from YouTube, just type it in the chat box. So today we are not having class in Google Meet, my dear. We are having only in Zoom and YouTube. Okay. Okay. So has anyone got the answer? Has anyone got the answer? JNB Bhavnagar, JNB The Hood. If you have got the answer, just type it in the chat box. Okay. Okay, we'll discuss. So we are asked to find out the compound which has lowest pKa. So we know that pKa is inversely proportional to acidity. pKa is inversely proportional to acidity. Means if a compound is having lowest pKa, then that particular compound is more acidic in nature. So from the given four options, you see carboxylic acid group is there, and in option 1 to the carboxylic acid an ethyl group is attached. So who is this ethyl group? They are alkyl groups, right? Alkyl groups are electron donating. And in option B also, we have isopropyl group attached to the system. Isopropyl group, again it is an alkyl group which donates the electron to the carboxylic acid. And in case of option 3, you see hydrogen is attached to the carboxylic carbon. So hydrogen is not an alkyl group, means it is neither an electron withdrawing nor an electron donating group, right? So coming to option 4, we are having a methyl group, which is electron donating in nature. So all the electron donating groups are called as plus I groups. And here in all the four options, we are having the alkyl groups as an electron donating. So what does plus I groups, that is positive inductive effect, will be observed in all the four compounds, and the compound which has the electron donating group attached to the C double bond O system will have highest pKa value. Okay, means they are more acidic. Electron releasing group increases the more basicity. Electron releasing group or electron donating group increases the basicity of the compound. In case of option 3, we are not having electron releasing group. So what happens here? Here the compound will be more acidic in nature compared to the other three, and it will have the lowest pKa value. Okay. So option 3, that is formic acid, is the correct option for this question. Got it? Option 3 is the correct answer for this question. Shall we move on to the next question? Hope this question is clear to you. I'll go for the next question. Question number 4 for today. So consider the above reaction sequence and find out product C in the sequence. So you can take 10 to 30 seconds and you can try to find out the answer. Good evening, Jain, Viशाखापट्टनम students. Good evening to all. You want me to repeat? Want me to repeat which question? Last question, question number 3, you are asking? Yeah. Question number 3, right? Yeah. Okay, I'll show you. You want me to explain or you want to copy it? So pK is inversely proportional to acidity here, and the electron releasing groups such as alkyl groups will decrease the acidity. And in option 3, we are not having the alkyl group, that is electron donating group, we are not having in option 3. So that compound remains more acidic in nature since its pK value will be very low, as it doesn't have electron donating groups attached to it. Got it? So you can write like this: electron donating groups decreases the acidity, decreases the just a second. Okay, then fine, no problem. Okay, I'll go for the next question then. Okay, students, try to find out the product C in the sequence. Has anyone got a compound A? Has anyone got compound A? So no issues, students, no issues. You're welcome. Try to find out the correct answer for this question. Question number 4. What could be the correct answer for this? Has anyone got the answer? Okay, let's do it. Let's do it. So there is a compound given and bromine is reacted on it and we are getting compound A. So here reaction with bromine is called as bromination. Reaction with bromine is called as bromination. So from bromination we get Br plus electrophile. Electrophile will be generated there and it will go and substitute these two carbon. Why? OH is an electron donating group. So because of that ortho effect arises and the CHO is an electron withdrawing group. If an electron withdrawing group is attached to the system, the electrophile goes to the meta position, right? So for this aldehyde group, this is the meta position. So the bromine goes to the ortho of OH and meta to CHO. Okay. So this is compound A. And this compound A is treated with NH2OH. So what is the name of NH2OH? It is hydroxyl amine, right? So this we have studied under the reaction with ammonia in chemical properties of aldehydes. Okay, I'll write the CHO part like this so that you can understand. So it is C double bond O and H. So what we are going to do, we are going to add this NH2OH to the carbonyl carbon. Okay, so we are going to eliminate this H2O from here, H2O from here, and the NOH will be added to the carbon. So what we will get? We will get C6H5 and bromides are substituted. And here there is a hydrogen attached to it already and now double bond NOH. We are getting an C double bond NOH compound which is called as oxime. Okay, this is compound B. And compound B is treated with P2O5. So what is the role of P2O5? P2O5 is a dehydrating agent. P2O5 is a dehydrating agent. So what is dehydration? Dehydration is removal of H2O, right? So H2O will be removed from this part like this. H2O will be removed from this part and you will get a triple bond here. You will get a triple bond. So what could be the answer? It is OH, Br, and here we are getting a cyanide group attached to the system. Okay. So what is the answer? This is compound C and compound C is given in which option? It is given in option 4, right? So option 4 is the correct answer for this question. Okay. So first bromination occurs, which is an electrophilic substitution. And next comes the reaction with hydroxylamine, which leads to the formation of oxide. Then on treatment with a dehydrating agent called P2O5, we are arriving at compound C, a cyano compound. Okay. So is the question clear to you? Shall I move on to the next question? Or if you want me to explain any of the part, I'll just explain it once again for you. If you're having anything like that, just let me know. Okay. Thank you so much, students. Thank you. I'll go to question number 5. So when the compound is reduced with lithium aluminium hydride, the compound obtained will be when the given compound is treated with lithium aluminium hydride, the resulting compound will be. So what is the answer? Option A. That's great. That's great. So what is happening? So this compound is treated with lithium aluminium hydride. Lithium aluminium hydride is a strong reducing agent which will reduce only the C double bond OH part. It will not reduce the alkene system. Okay, it will reduce only the carboxylic acid to primary alcohol, that is CH2OH. So option 1 is the correct answer for this question. Great. Yeah, reduction. This reaction is called as reduction, where lithium aluminium hydride is used as a strong reducing agent. Okay. I'll go to question number 6 then. Question is very easy. I'll go to question number 6. Identify the reagents A and B respectively in the following reaction. So two reactions are given to you. Reactant and product is given and you are asked to find out the reagents from the given options. So what is the correct answer? The answer is option 1. So you can see here COOH is getting converted to COCl. That is, we are getting acyl chloride from carboxylic acid. So SOCl2 is the reagent which converts OH group to Cl group. Okay, so SOCl2 is the reagent A. And coming to the second reaction, COOH group is getting converted to CHO. So it is also a reduction, right? So what is the name of this reduction? This is called as Rosenmann's reduction. So hydrogen in presence of palladium barium sulfate is called as Rosenmann's reagent, and that will reduce the COOH part to CH2. Okay. So option 1 is the correct answer for this question. Yeah. Option A is the correct answer. Good. Good. I'll go to question number 7 then. Let us move on to question number 7. So identify the final product D obtained in the following sequence of reaction. So identify the final product D obtained in the following sequence of reactions. So I'll give you 30 to 45 seconds for this question and try to find out the compound D and tell me which option is correct. Has anyone got the answer? Okay, we'll try to discuss. We'll try to get the answer here. So see, students, so ethanol is treated with lithium aluminium hydride and on acid hydrolysis forms alcohol. So what type of alcohol you will get? You will get ethyl alcohol. You will get ethyl alcohol. That is CHO will be converted to a primary alcohol. That is CH2OH. So this is compound A. Ethanol is compound A. Ethanol is compound, yes, ethanol is compound A. And ethanol A on reaction with H2SO4. So what is the role of this H2SO4? It is again a dehydrating agent. Sulfuric acid, P2O5, they are dehydrating agents. Okay. So what this dehydrating agent will do? It will go and remove the water molecule from the alcohol, ethyl alcohol. So which hydrogen and which OH will be removed from the ethyl alcohol? Always beta hydrogens are removed. So who is the beta hydrogen? The carbon which is attached to the OH is alpha carbon and this is beta carbon. So one of the beta hydrogen will go out as H plus and OH will go out. And here you will get a double bond. So you will have CH2 double bond CH2. and this is compound B. So here we are eliminating the water using a dehydrating agent called H2SO4. Okay. And compound B on reaction with HBr. Compound B on reaction with HBr forms compound C. So what happens? So break this double bond and add hydrogen to one carbon and bromine to the other carbon. Since the compound B is a symmetrical alkene group, the addition of this HBr can take place in either of the ways. You don't have to follow any of the rule called Markovnikov or anti-Markovnikov since the alkene is symmetrical. Okay. So what could be the formula for compound C? It is CH3, CH2, Br. So this is compound C. And compound C is reacting with bromobenzene in presence of sodium metal and in dry ether as a solvent. So what is the name of this reaction? So we are having one alkyl halide and it is treated with an aromatic haloarine. Haloalkane is treated with haloarine in presence of sodium metal. So this reaction is called as Woods-Fittig reaction. You would have studied in your previous haloalkanes and haloarenes lesson. Okay, so this is Woods-Fittig reaction where 2 NABr will be eliminated and the alkyl part and aryl part will get connected with each other. So the compound will be, so with this bromobenzene is reacted, no? This bromobenzene is reacted and in presence of 2 sodium metal. So 2 NABr will go out and you connect these two. So what you will get CH3, CH2 and C6H5. So this is called as ethyl benzene. This is called as ethyl benzene. And where is our ethyl benzene in the 4 option, given 4 option? Yes, option 4 is the ethyl benzene. So option 4 is the correct answer. Okay. Shall we move on to question number 8? Shall we move on to question number 8? I think we can go for question number 8. Yes. So question number 8 states that methyl magnesium bromide with carbon dioxide in presence of dry ether forms Y and with H3O plus it forms Ez. So you have to identify the compound Ez from the following. You have to identify the compound Ez from the following. Nandini Reddy is there? Okay. Good evening, Nandini. So students try to find out the answer. Compound Ez is very easy reaction. No? Got the answer? Good evening, dear. So students find out the answer for this question. So CH3 Mg Br is treated with carbon dioxide, which is called as dry ice. Okay. So what is the structure of carbon dioxide? C double bond O, C double bond. So in presence of dry ether. So just you add this Grignard reagent to the C double bond O system. So how to add this? Break the bond, add positive part to oxygen and the negative component to carbon. So what you are getting? C double bond O and CH3 here O minus and Mg Br plus. So this is compound Y. And compound Y is treated with H3O plus, acid hydrolysis. So on acid hydrolysis, the given compound produces acid, right? You have to break this OMG bond and basically we add water molecule to the system. You add the H plus of water molecule to oxygen and OH of water molecule to MgBr. So at the end what we will get, it is C double bond O, CH3 and OH plus MgBr OH. So this is compound Ez. What is compound Ez? CH3COOH. CH3COOH is called as acetic acid. The common name for CH3COOH is called as acetic acid. And what is the IUPAC name of acetic acid? Yes. What is the IUPAC name of acetic acid? IUPAC name of acetic acid is ethanoic acid, right? Yes, good. Ethanoic acid. So here in the given options, we are having acetic acid in option 1, in which that is the correct answer. Okay. So now let's go for question 9. Let's go for question 9. So two different reactions are given, and in the above reactions, you have to find A and B. Find A and B from the given reactions. Take few seconds and try to get the answer. Has anyone got compound A? Has anyone got compound A? What is compound A? Compound A is CH3CHO. No, no. Okay, we'll discuss. No issues. Listen, lithium aluminum hydride is a strong reducing agent. It is a strong, yeah, yeah. Now you are correct. It is a strong reducing agent, and this will reduce the C double bond OOH, that is carboxylic acid group, to a alcohol group. So compound A would be CH3, CH2 and OH. So it is CH3, CH2 and OH. The CH3, CH2 and OH. Okay. And the CH3, CH2OH, it is treated with acetic acid. And in presence of acid, it forms B. So what could be the formula for B? Alcohol. Alcohol is reacting with acid. When alcohol reacts with acid in presence of H plus, it forms ester. It forms ester and water, right? Acid plus alcohol forms ester and water in presence of acid. So how to get the ester? So the oxygen, hydrogen from alcohol and OH from acid will go out as water, and at the end we have CH3, CH2, O, C double bond O, CH3. So this is the ester we are getting from the given system. That is ethyl ethanoate we are getting. So option 4 is the correct answer. Compound A is ethanol and compound B is ethyl ethanoate. Yes. Yes. Option 4 is the correct answer for this question. Good. Good, students. It is esterification. Second reaction is esterification, and first is the reduction of carboxylic acid to alcohol. Okay. So let's go for question 10. Let's move on to question 10. So in the following reaction, X and Y are respectively. So we have to find out compound X and Y again. So acetic acid is treated with ammonia and it forms X. Let me know in the chat box the formula of X. And then X on heating forms Y. Forms Y. What could be the correct answer? You can get the answer just by finding out compound X itself. If you find X, you can find out the correct answer for this question. Has anyone got? So all these reactions will fall under the chemical properties of carboxylic acid. Okay. Has anyone got the answer? Okay, then I'll discuss. So CH3COOH, CH3COOH, CH3COOH with ammonia forms ammonium acetate. It forms a salt of formula CH3CO minus and NH4 plus. That is, here we are having a OH bond, no? Nitrogen of ammonia contains a lone pair, and that lone pair will go and attack this hydrogen, and the electrons will be shifted to oxygen. So we get a salt. We get a salt. Yeah, yeah. We get a salt. So this is compound X. CH3CO minus NH4 plus is compound X. So compound X on strong heating forms Y. On strong heating, what happens? Water is getting eliminated. So how does it get eliminated? It goes from NH4, two hydrogen goes there, and oxygen from the carboxylate ion but comes out. So finally, what we are having in the structure? We are having CH3, CO, and NH2, which is called as amide. And this is compound Y. Okay. So it is given in option 2, right? Option 2 is the correct answer. We are getting ammonium acetate and acetamide as the answer. So option 2 is the correct answer. Okay. All these reactions are very, very important. They are very easy, but they are important. Okay. And coming to question number 11. Again, you are asked to find out the reagents X and Y from the given reaction. Find out X and Y reactant and products are given to you, and you have to find out the reagents. You have to find out the reagents. Just take 30 seconds to 45 seconds and try to find out the answer. Option B. Okay, let's check. Let's check. So see here, OH and COOH are attached to the system, which is called the salicylic acid. The name of this compound is salicylic acid, right? This is salicylic acid. And the salicylic acid is getting converted to an ester containing compound, that is OCOCH3. So means OH bond is getting cleaved here. So when does this OH gets cleaved? When it reacts with acyl chloride or alcohol or acetic anhydride. Only if OH reacts with these two, the bond gets cleaved. So here you can see acetic anhydride, you can take CH3, C double bond O and C double bond O CH. Okay, this is acetic anhydride in presence of H plus. So the OH bond cleaves and the CH3COOH will go out as acetic acid, and the CH3CO, this acyl part will be, this acyl group will be attached to the oxygen here. So what we get? We get OCOCH. So the reagent X is acetic anhydride. Okay. And come to Y. So in on reaction with Y, a salicylic acid is forming another compound where the reaction occurs in the COOH part. Okay. So the acid reacts with alcohol. Acid reacts with methanol, and the CO bond gets cleaved here from COOH, and this is the salicylic acid part. And the CO, this bond cleaves, and the OH bond cleaves. So acid and alcohol, they react to give this ester with the elimination of water. Okay, acid and alcohol gives ester. So we'll get the given compound from the reagent Y. Yeah, option B is the correct answer. You guys are doing really great. So option B is the correct answer for this question. Okay. So moving on to question number 12. Moving on to question number 12. So just take the question. Acetic acid is reacted with metallic sodium to form hydrogen. To form hydrogen and X. When X is heated with soda lime, Y and sodium carbonates are formed. Y is. So we are asked to find out the compound Y. Try to find out compound X first and then try to find out the compound Y. You can get the answer within 30 seconds. That much easy it is. If you have got the answer, just type your answers. Option 3 is compound X or Y. Option 3 is compound X or Y. Nandini? Compound X, yes. Option 3 is compound X. And now you try to find out compound Y. Compound X is option 3. That is acetic acid. CH3 COOH is reacted with metallic sodium to form hydrogen gas. To form hydrogen gas and compound X. Okay. So here 2 moles of acetic acid reacts with 2 moles of sodium. Here OH bond will break and 2 hydrogens will go out as H2. 2 hydrogens will go out as H2. Yes, correct. 2 hydrogen will go out as H2 and sodium will form the salt. Sodium will form the salt. That is, we will get CH3, CO minus and Na plus. Sodium acetate will be formed as compound X. And this compound X is treated with soda lime. So what is soda lime? What is soda lime? Yes, soda lime mixture is NaOH, NaOH and calcium oxide. This mixture is called as soda lime and this reaction is called as decarboxylation reaction. Yes, it is called as decarboxylation reaction where Na2CO3 goes out and the R group will be attached to a hydrogen. So here the R group is methyl group, right? Methyl group with one more hydrogen is CH4 and this is compound Y. So we are getting methane. So instead of this methyl group, if you are having C2H5, can you name compound Y if R group is C2H5 for the same mechanism? Can anyone let me know the formula for compound Y if R group is taken as C2H5 for the same sequence? For this question, CH4 is the answer. Just give me the answer if R group is taken as C2H5 for the same set of sequence. It's very easy, no? Very easy, right? The R group will be added with hydrogen. That's all. And I gave you C2H5 as the R group. C2H5 with one more hydrogen is what? C2H6, right? C2H6 is ethane. Okay? C2H6 is ethane. Yes, good. Good. C2H6 is ethane. So this is how you can solve these kind of questions. So shall I move on to next question? Question number 13. Shall we go for question number 13? Yes. So question number 13 states that when propionic acid is treated with aqueous sodium bicarbonate, the carbon dioxide is liberated. The carbon from CO2 comes from where does the carbon dioxide comes? It is from methyl group or carboxylic acid group or methylene group or bicarbonate. What is the formula for propionic acid? It is a 3-carbon containing acid, right? It is CH3, CH2, C double bond OOH. This is propionic acid. Okay, it is treated with aqueous sodium bicarbonate. What is the formula for sodium bicarbonate? NaHCO3 sodium bicarbonate. And this reaction we have seen under the chemical that is acidic nature of carboxylic acid. We have studied this reaction. And from this we get 3 products. One of the product is CH3, CH2, COO minus and Na plus salt. Sodium salt is one of the compound and the other compound is H2O and the third compound is CO2. So this is the reaction and this CO2 carbon has come from which compound they are asking. So we are having only 2 different reactants. One is the carboxylic acid and the other one is bicarbonate. So carboxylic acid carbon remains same here in the salt. So means this carbon would have come from which part? It would have come from the second reactant which is bicarbonate, right? It would have come from this carbon. So the answer is it has come from bicarbonate. It has come from bicarbonate. Yes, option D is the correct answer for this question. Okay. Shall I move on to next question? Yes. Question number 14 is on your screen. You have to match list 1 with list 2. It's very easy. Just find out the answer within a fraction of a second. Hell-Vollard-Zelinsky reaction reagents. Whose HV is a reagent? Option D. I'm getting option D. Okay, let's check. So HVZ reaction reagent is Br2 and red phosphorus. You have to use Cl2 or Br2 in presence of red phosphorus and on reaction with H2. So this is HVZ, Hell-Vollard-Zelinsky reagents, right? And in iodoform, we use sodium hydroxide as a base and iodine. And in ethyl reaction, chromyl chloride is used. Gattermann-Koch is carbon monoxide with HCl. So A goes to 3, B goes to 1, C goes to 2, and D goes to 4. So which is the correct answer? This is the correct answer. Option C. Option C. No. Just to see once again. A goes to 3. A goes to 3. Option C is not the correct answer. Option B is the correct answer. Option B is the correct answer. Okay, ethyl reaction we have used in the preparation of benzaldehyde. No, there we used chromyl chloride as the reagent. And this is used in iodoform. It is used in iodoform. Yes. Yes. Option B is the correct answer. In Gattermann-Koch, we used carbon monoxide, no? From benzene. Directly we have prepared benzaldehyde, right? So it is very easy. So option B is the correct answer. Just don't select the answer just by seeing only one thing, one compound. Just check for all the 4 options given and then try to select the correct answer. Okay. So patience is also very important. Patience is very important. Shall I move on to the next question? Shall I move on to the next question, students? Okay. Okay. So a sequence is given to you and you are asked to find out compound C. You are asked to find out compound C from the given sequence. So try to find out compound C. Take your time. Take 20 to 30 seconds and try to find out compound C. Has anyone got compound A? Has anyone got compound A? What is compound A? So here you see CH2OH is there and HBr is given. This is basically the nucleophilic substitution reaction, right? So OH nucleophile will be substituted by Br nucleophile and the compound A looks like this. It is C6H5. Option B. Yes, good, correct. Option B is the correct answer. And here compound A is CH2Br. And this compound A is treated with KCN. So again, Cn minus is the nucleophile. It will go and substitute the Br nucleophile. So what we will get? We will get C6H5, CH2, Cn, right? This is compound B. And compound B on hydrolysis, that is on reaction with H3O plus acid hydrolysis on heating. So always remember, cyanide group or the nitrile group on acid hydrolysis always forms corresponding carboxylic acid. The cyanide on hydrolysis always produces the carboxylic acid. So Cn will be converted to COOH. You have to study the mechanism. Mechanism in the sense, on treatment with this particular reagent, this part will be converted to this part. Like that you have to study. Okay. So Cn on acid hydrolysis forms carboxylic acid. So which is the correct answer? Some of you have already got it. Option 2 is the correct answer. C6H5, CH2, COOH. Phenyl acetic acid is the name of this compound and it is given option 2, which is the correct answer. So shall we move on to the next question? Shall we move on to the next question? We'll do one more question for today's class. So the correct order of increasing acidic strength of the compounds. So this is the last question for today. So 4 different compounds are given to you and you have to find out the increasing order of acidic strength. Increasing order of acidic strength. So try to find out the answer. Try to find out the answer. Has anyone got the answer? So on what basis we have to get the answer for this question? Here they are asking you the acidic strength, right? And you look into the 4 given options. All are carboxylic acids. All are carboxylic acids. All are COOH containing compounds. And in the option, in the compound A, we have CH3 group, which is an alkyl group. Option A. Yes. So it is an alkyl group which donates the electron to the carboxylic acid. And here we are having OCH3. Me means CH3. Okay. So we are having CH2OCH3. And here CF3 is given. And here also we are having an isopropyl group attached to the carboxylic acid part. So in the first compound, CH3 is there. CH3 is there. And next, in compound B, we have OCH3. Compound B, we have, we have OCH3. We have OCH3. And in compound C, we have fluorine attached. We have the fluorine CF3 attached to the carboxylic acid part. And lastly, we are having isopropyl group. That is, a carbon is attached with 2 methyl groups. That's attached with 2 methyl groups. So these are the 4 substituents attached to the carboxylic acid. Okay. And now, fluorine is more electronegative and it withdraws the electron from the carboxylic acid and makes the carboxylic acid more electron deficient so that it becomes more acidic. Got it? So fluorine is more electron withdrawing in nature. So it withdraws the electron from the carboxylic acid, making the C double bond OH more electron deficient. More electron deficient species are called as acids, right? So minus fluorine and OCH3 is next to it, and the CH3 They are electron donating, and isopropyl group is more electron donating in nature compared to methyl group. Okay. So this is the order of acidity. Fluorine always increases the acidic nature. Acidity increases on the substituents. So just you try to find out the answer. So the fluorine containing compound is more acidic in nature, means compound C is more acidic. In three options we are having compound C. And next is OCH3, compound B should come next to it. So among 1 and 2 is the answer. False. And next comes the CH3 group containing compound, which is A, and then comes D. In the isopropyl group is present. It is more electron donating in nature. It increases the electron density on the carbonyl system, making the system more basic. Okay. So from lesser acidic value to larger, more acidic value is the increasing order, which is given in option 1, D, A, B, C. Okay. Students, do you have any doubt here? Plus I groups decreases the acidity. That is a concept. Plus I groups decreases the acidity. Okay. They make the system more basic. And all the alkyl groups are more electron donating groups. They increase the basis. Got it? So this is all for today. And if you are having any doubt in all the 16 questions I have discussed, you can let me know in the chat box. I'll give you some 15 to 30 seconds. You can let me know in the chat box if you want me to repeat any question, or if you're having any doubt in any of the question. If you are not having any doubt, or if everything is clear to you, just give me a thumbs up so that I can understand that you have understood. Okay. So no doubt, students. Okay then. Thank you. Thank you so much to all of you. So we'll continue the thing in the next class tomorrow. Okay. Thank you, students. Thank you so much for listening. Thank you all. Thank you.